Let's try to solve Leetcode weekly contest 402 a bit late today. Let's try the first problem. Count pairs that form a complete day. 1. Uh, Given an integer array hours representing times in hours, return an integer denoting the number of pairs I, j such that hours I plus hours j forms a complete day. That means hours I plus hours j is 24. And so we can solve it in n square also. So let's solve that in that way only. I should not be equals to j, right? I less than j. I less than j. So let's denote n as hours dot size and denote answer equals to 0, and do a in square for loop 0 I less than n I plus plus, and for integer j equals to 0 j less than I j plus plus. If hours I plus hours j is 24, do answer plus plus and just return answer. Let's use example test cases and run the code. This is 1 and 0. The answer should be 2 and 3. Exact multiple of 24 hours. So the modulo 24 should be 0. Uh, should be 0. Let's do this. Hours I plus hours j modulo 24 should be 0. Let's run the code. 2 and 3, and it's 2 and 3. Let's submit the code. Uh, exact multiple of 24 hours. For example, 1 day is 24 hours. Yeah, this should be right. Let's submit. Yes, it's accepted. Let's jump on to the next problem. What is this? To back to contest. Count pairs that form a completed 2. I think the constants is higher. Given integer, okay. The problem is exactly same, but the constants are higher. So how we can solve that? Uh, okay. Um, so A modulo uh, A modulo 24 plus B modulo 24 should be 0, right? Then we can say that we take modulo, then b equals to 24 minus a. B equals to 24 minus a. I think we can solve it using map. So let's take one map. uh, Map of let's define ll as long. So let's say a map of ll comma int mp. Now we'll iterate over hours, and also declare answer as 0. uh, for integer I in hours, we'll do what? We'll do hour in hours. uh, and we'll take modulo 24. Yeah, integer mod equals to hour modulo 24. We'll do answer plus equals to mp of 24 minus mod. Now mod could be 0 also, so you have to take modulo 24 again, and we'll do mp of mod plus plus. Just return answer from here. Let's use example test cases now. Run the code. 2 and 3. Let's submit the code. Runtime error. Okay. Cannot be cast in int. Okay, so answer should be declared in ll also. So let's submit now. It's accepted. Let's jump back to the contest. Let's solve the third one. A magician has various spells. You are given an array power where each element represents the damage of a spell. Multiple spells can have the same damage value. It is a known fact that if a magician decides to cast a spell with a damage of power I, They cannot cast any spell of damage power I minus 2 power I minus 1. Okay. Each spell can be uh, cast only once, return the maximum possible total damage the magician can cost. So if he make put 4, then 4 1 is possible, but 3 is not possible. Okay. The maximum possible damage of 6 is provided by casting. Okay, so he can cast, if he casted 1 once, then he can cast again 1, but he can't cast 0, minus 1, 0, uh, 2 and 3. Okay, and we have power dot length is 10 to the power 5. I think. Okay, and the power I could be 10 to the power 9. Okay, so we can take frequencies, right? We can take frequencies. Mm, is there, we sort based on to the frequency. So let's say we have some pairs like this. 1 is present 2 times, 3 is present once, and 4 is present once. Then we can do something like, for 4 the value could be, here the value is 2, and here the value is 3, here the value is 4 plus 2, 6. Okay, 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 got it. Let's take one frequency array. So we'll define LL as long long again, because we'll need that. Now we'll take one frequency array, map int comma int frequency, and we'll need this. Now we'll need another thing, let's call that dp. Now we'll iterate over the power, po in power. We'll do frequency of p plus plus. Now we have to take something minus 2, right? Mm. We have to take something minus 2 if 4 minus 2 is present in the array, or something less than 4 minus 2 is present in the array, so we have to take some kind of lower bound. So for that we will also need one set, so let's call that as powers. Okay, now we'll iterate over mm, uh, entry in the map in the frequency, and let's I think we have to declare answer also. Let's do ll answer. Now frequency plus plus. Now we'll try to find equals to powers dot lower bound. We'll do our let's say our val equals to entry dot first, and the frequency will be entry dot second. Now powers dot lower bound, we'll try to find this minus 2, so we'll try to find value minus 2. Now if u not equals to powers dot begin, that means that the value minus 2 is present, but we have to take we have to decrement the pointer, so to do u minus minus, and we'll do dp of val equals to dp of star u plus f, uh, and we'll do answer is equals to maximum, otherwise else dp of val equals to if nothing but answer equals to maximum of answer comma dp val. And let's insert is dot pause dot insert val return answer. Let's run the code. Compile error. uh, okay, we have to take dp val should be ll, so let's do ll map of ll comma ll. Run the code. Answer is 3 comma 3, but the answer should be 6 comma 13. So this should be f into val, and this should be f into val. Answer is 6 comma 13. Let's submit the code. I think this should work, right? If u not equals to pause dot begin. Yeah, wrong answer it is giving. Output is 30 but expected is 31. Spell can be cast only once. Return the maximum passive possible value. Why the answer is wrong here? 10 is present twice. 20. 7 is present once. 27 and 2 is present. Okay, we have to take we have to take maximum of these two things. So dp val should be answer, right? So dp val should be answer because dp val could be the we can take val minus 1 also, right? That's what we have missed. So we can take val minus 1 also again. Let's run the code here. 31. Yeah, I think this should work. Runtime error. Sign integer overflow. Solution if into val. Where we are using int. Okay, we have to take again ll here. And anything else we have to do? Val into if we are doing, so nothing else I think. This is accepted. Okay, so we have submitted twice wrongly. Let's back to the contest. Okay, now peaks in array. If peak is an ARR, peak is an array. ARR is element that is greater than its previous and next element. You are given an integer array nums. You have to process the queries of two types: one comma li comma ri. Determine the count of peak elements in the range li comma ri. Determine queries I. Change the value. Okay, okay. So this is kind of a segment tree. This is a segment tree, definitely. 1 comma li comma ri. 3. Let's take the example. 3 1 2 4 5. So the first query is 2 comma 3 comma 4. So change the index 3 to value 4. Change the index 3 to value 4. So this index to be 4 changed to value 4 with 3 1 4 4 5. And then what is the operation? Next operation is 104. So 0. So Eli and Ri could be 0 also. Okay, yeah. So we are using zero based indexing. Now, mm, number of peaks from 0 to 4. So this is, there is no peaks, right? Answer is 0. Yeah, the answer is 0. There are no peaks. So this is a straightforward segment tree, I think. When we are updating one value at a specific index, and we'll check, we'll try to we'll be needing two segment trees, right? We'll be needing two segment trees, one for this and one for that, or what? Yeah, only one segment tree will be needed. Uh, only one segment tree will be needed. So we'll be maintaining our. Let's take one other example. Let's take 1, 2, 5, 2, 6, 1. Here there are two picks. There are two picks. So our segment tree will contain 0, 0, 1, 0, 1, 0. Now let's say we're changing this value back to 1. Then our segment will be like 0, 0, 0, 0, 0, 0, 1, 0. This is nothing but a segment tree. Let me copy my segment tree template. I have to stop the. I have copied the template. Let's paste it here. So this is checksum template. I have used in some other Leetcode contest also. This one. So we have to modify the value segv with val. We can do that. Yeah, we don't really need to check anything here. Yeah. Now let's make the pick array. So let's denote n as what is the value of this 10 to the 5. So 4 and 10 to the 5 is fine length. So n is will be nums dot size. Now we are done with this, right? In is nums dot size. Now what we'll do, we'll just define some ss. Let's initialize the segment tree. So integer I equals to 1, I less than n minus 1, I plus plus. If nums I greater than nums I plus 1 and nums I is greater than nums I minus 1 also, then it is big. Then we have to do update. So we'll do ss dot update. What best indexing are we using? We are using I think one best indexing. So we have to pass I plus 1. I plus 1, the value will be 1. Now let's iterate over queries. So for vector of int query in queries. Now the type, the query 0 is equals to 1, then this is the update operation. Else we'll be needing vector of int answer also. Else this is a get operation. Else just return for this, just answer dot pushback. Ss dot query. What we need only query start and query end. So we'll need query 1 plus 1 comma query 2 plus 1. Otherwise if this is a update operation, then what we'll do, let's do peak of query 1 equals to query 2. Okay, we are not we don't have any peak array, right? Now is peak, let's declare boolean is peak. Is this condition, this is the condition. This should be our let's declare I as query 1. Let's declare I as query 1, and this is our p is peak condition. Okay, and let's declare val as query 2. and is speak now and is speak after. Let's take these two things. This is speak now, and this will be speak after. Speak after. Now this should be, we have to compare with val, not num psi minus 1. Sorry, not with num psi. Now if you speak now and speak after different, speak now, okay, we can directly do speak after, right? We don't need to speak now. Yes, we don't need to speak now. We can take integer this. Now we'll just do ss dot update, uh, ss dot update I plus 1 and speak after, and we have to also update nums I as well. Yeah, this is right, I think. Just we have to return just answer from here. Use example test cases and run the code. LL is not defined, we have to define LL again. Let's run the code now. Runtime error. Why there is a runtime error? What are we doing wrong? Query 0 is 1. Okay, okay. Only if I equals to 0, or I equals to n minus 1. We just have to do answer equals to val earlier, right? We can do this. Yeah, I equals to n minus 1 just to continue. Now I think this should work. 0 and 1. 0, okay. It is only returning 0 and 1. But it should return. Why it is only returning one value? This is strange, right? What? I equals to 0 and I equals to n minus 1 is to continue. Let's print query 0 here. We have made some silly mistake somewhere. 2 1 2 1 1, but the answer only contains one value. Let's print queries 1 and query 2 here. Are we returning? No, we are not returning before this also. Okay, this should be query 2. Let's run the code again. Okay, if query 0, if it is 2, then it is the update operation, right? If it is 2, then it is the update operation. That was the mistake. Let's clear these things. Let's run the code. This is 1 1 and 1. Okay, why it is 1? The first one is the speak after well greater than num psi plus 1 and well. Okay, 7b equals to well. What mistake are we making? We are making some mistake. Query 1 is the I. We are making some kind of mistake. Let's print speak after here. Uh, let's run the code from here. 3021. Let me take 1 minute. I'm back. Now let's jump back to the code. 30, that means 3 index is getting converted to 0. That is right. Right. Let's print val here. So let's print ss and val here. We'll know from this example. Let's run the code. Now it was 3 1, and after that it is becoming 3 0. So what is the mistake we are making? That is one important thing. The answer is still 1 after the update operations. Okay, we have only made 3 1, and after that we are making 3 0. Let's only run the first test case. Let's only run the first test case. 3 is made to 1, and then 3 is made to 0. Then why 4 is made to 0 again? There is definitely something wrong. Okay, query 1 plus 1. 4 is right. We are changing the, what is wrong here? Let's print the entire thing. Sum equals to this is dot query 1 comma 5. We'll get to know from here. 3 1, sum is 1. Let's print this outside also. There's something wrong with the segment tree itself, I think. Initially sum is also 1, and after that sum is also 1. We are changing seg v to val. We are doing seg v equals to seg of 2 into v plus 1 plus seg of 2 into v. We are doing seg v equals to val. Three 1 and sum equals to 1, then 3 is changed to 0, when why 4 is changed to 0? That is one point. 4 should not be changed to 0, right? 4 should not be changed to 0. Why 4 is getting changed to 0? Sum is printed thrice. Sum should be printed thrice only. 3 is changed to 0 and 4 is changed to 0. Why is that? index greater than mid, we are doing mid plus 1 AC 2 into 1 1 5 1 index comma val. We are passing index comma val, right? Let's do this. SS AC. Let's pin this. Let's run the code here now. 1 1 5 1 3 1 4 1 3 1 4 1 3 3 4 1 3 3 3 1 3. It is right. 0 4. It made 0 and the index is 4. It is we are making ss dot update I plus 1. Okay. Where are we wrong? 3 comma 0. Let's do this. I comma is big. Let's run the code. 3 is big 0. So it should be 4 and 0. Yeah. Should be 4 and 0. The fourth index we have to make 0. But here we have to make the third index 1. Why? If nums I greater than nums I plus 1 and nums I greater than nums I minus 1, we are doing ss dot update I plus 1 comma 1. So this, okay. So that is the case. When we are changing some index, its adjacent index are also getting changed. Okay. You speak after for the current index. You have to check the two previous index also. If I minus 1, okay, if I minus 1 is greater than 0, then we have to check this condition similarly for the I minus 1. Okay, let's do this. This should be nums I minus 1. Nums I minus 1 should be greater than I, and nums I minus 1 should be greater than nums I minus 1 should be greater than nums I minus 2. This is the two conditions we have to check. This for I minus 1, and similar thing is for I plus 1 if I plus 1 is less than n minus 1. Okay, we have missed this part completely. So nums I plus 1 should be greater than nums I, and nums I plus 1 should be greater than nums I plus 2. Okay, that is the two conditions we have to check. We have to modify the value of I also, and here we have to modify the value of I plus 2 because we are using one based indexing. Let's erase these things, erase this, and let's erase this these also. Okay, let's run the code now. This is 0. Now use example test cases and run the code again. 0 1 1. So the answer should be 0 0 1. So again we are wrong somewhere. If nums I minus 1 greater than nums I, and nums I minus 1 greater than nums I minus 2. So okay, I and I plus 2. Yeah, we are right here. But there is still one mistake. if I equals to, okay, we can't do this, right? We can't do this because this might be modifying the latter values. So this declared integer is picked after previously. Yeah. And if only this condition is satisfied, then we'll modify the value. Yeah. If I greater than 0 or I less than n minus 1 and I less than n minus 1. Okay, I think this should work this time. Yeah. No, not really working. If I greater than 0 and I less than n minus 1, this pick after will be well greater than num. I minus 1 greater than 0. We are doing this. So what is the second case? 4 1 4 2 1 5. Let's take this case. 4 1 4 2 1 5. 4 1 4 2 1 5. And initially the update is update the second index with value 4. So update the second index means this index to value 4. This is already there, right? So it is already set to 4. So this 4 1 4 2 1 5 only, and after that we have the first query operation from 0 to 2. From 0 to 2, this is a peak, but uh, the first and last element of the array or a subarray cannot be a peak. So we have to take query. So let's say we are trying from 0 to 2, then we have to take query 1 plus 2 and query 2. Now there is a check, right? For query there is no check, but let me add the check. If query start is greater than query end, just return 0. Yeah, query start greater than query end or query start less than 0. Less than 0, yeah. Less than equals to 0. Let's take that. Let's run the code now. Yeah, 0 0 1. I think this is working as expected. Okay, let's submit this now. Yeah, this is accepted. Now I will try to explain each and every problem because one of my subscribers have requested that. So let's jump back to the contest and I will explain it from first to fourth, and then I will end the screencast. So let's jump onto the first problem. The first problem is quite easy. What we have to find is that if nums I plus nums j is a multiple of 24, so we have done the brute force solution of order of n square. So we are iterating over every possible pair I comma j, and we are checking that if ours I plus ours j is a multiple of 24 or not. If it is, then we are incrementing the value of answer. This is order of n square, but here n is around 100, so it is accepted. Now let's jump on to the next problem, which is a variation of this problem. Not a variation, it is just the constants are higher. Order of n square solution is not accepted. Now how we can solve that problem? Let's jump on that onto that problem, how we have solved that problem. So here order of n square is not accepted because the length of the array is 10 to the power 5. So we have to think something better. We have to think in order of n or order of n log n. So here you might observe that. Let me delete the entire thing. Let's just do this. So you might observe that if let's say I plus j is a multiple of 24, then the value could be like this. The value could be I could be 1, j could be 23, I could be 2, j could be 22, like that. So what we are saying that I modulo 24 plus j modulo 24 is 0, right? 24 modulo 24 is 0. Then we can say that I modulo 24 is nothing but minus j modulo 24. So minus j modulo something is nothing but we have to add 24 to here. 24 minus j modulo 24. So I modulo 24 is nothing but 24 minus j modulo 24. Okay. So that's why we are doing that. Our mod is nothing but I modulo 24. Then we are trying to find the value j, 24 modulo 24 minus mod modulo 24. Okay, and we are adding the value to this. So a number of j's present for the current I. We are just adding that to the answer. Okay, and at the end we have to also modify the MP of I value after the operation is done. Why we have to do after the operation is done? Because if for let's say I equals to 0, then j is also 0. So if we update the map before the operation is done, then we are counting I comma I pair, which is not needed. So that's why we have to modify the map value after the operation is done. So let's jump back to the problem. The solution has time complexity of order of n log n, which is accepted. Let's jump to the next problem. Here the next problem, we have made multiple wrong answers with long because we are not initializing with specific this with long or somewhere this with long. That's why we got some overflow error. So what is the problem? Problem is that we are given one array powers, so we can cast power I, but if we have casted power I, we cannot cast power I minus 2, power I minus 1, power I plus 1, and power I plus 2. So if let's say 1134, here one thing to observe is that we can cast same power twice. We can cast 1 and 1, but when we cast 1, then we can't really cast 3 because it is within the range power I plus 1, power I plus 2. So what we are trying to do, we are just sorting the array. We are sorting the entire thing. Let's say 1134 is already sorted, and we are also maintaining the frequency paired. So we are maintaining something like this: 1 comma 2, 3 comma 1, and 4 comma 1. Okay, so when we are at specific index I, what I am trying to do is that I am trying to find what is the value which is less than I minus 2. So I am trying to find the value less than 3 minus 1. So here nothing is present. So you can assume that 0 comma 0 is present, but that is not needed. So I am trying to find I minus 2 here, but I minus 2 is not present. Then our value will be this frequency multiplied by value. So the value will be here 3. Here the value is also 2. Now when in case of 4, we are trying to find something less than 4 minus 2. So less than 2. So we found this value 1. So we will do 2 plus 4 into 1, 6. Okay. Now here is one important case. Let's say 1 let's say we have something like let's say 5 comma 1, sorry, let's say 6 comma 1 is also present. Now let's say instead of this is 1 comma 8. Okay, let's say this is 1 comma 8. Now uh, when we are trying to find 6 minus 2, we'll get this pair, right? So we'll do 3 plus 6, 9, but that is not the optimal case. We have to take this pair because this is giving us 8, and the answer will be 8 plus 6, 14. So what we are doing here, we have to till the index I, we have to take maximum of previous all the indexes. Till the index I, you have to take maximum of all the indexes. So what am I doing here? Let's discuss the solution. So I am taking one frequency array and one dp array. Okay, now we are incrementing the value of frequency. Now we are iterating over each and every entry in the map. Now this map is ordered, so you can say that this is sorted. We are traversing in sorted order, in ascending order. Now we are trying to find powers is also a set. So when we are done with some index, we'll add that into the set. There could be some better solutions also, but this is also accepted because this is not adding some time complexity to this. So when we are done with one index, we will add that back to the set, and we are trying to find 6 minus 2. We are trying to find 6 minus 2 in the set. After we get the specific index, we will just decrement the set pointer by 1, because we will get something like 6 minus 2 will be 4. When we decrement the value by 1, we will get 3. Okay. Now if u is not powers dot begin, that means the element is already present. The element 6 minus 2 is present. Then we will do u minus minus, and dp of val is dp of the previous index, dp of 3 plus f into val. Otherwise dp of val is nothing but f into val. Now here is the important part. We are taking answer as maximum of answer comma val, and we have to set dp of val to answer, because after we done with the operation we have to change the value of this index dp of 3 back to 8, because we have got this 8 from this pair. Okay, so dp of val will be the maximum value of, so you can say that dp of val is the prefix max of val. Okay, and we are inserting val here. At the end we are returning answer. I hope you got the explanation. So let's jump back to the context, the last problem. Let's discuss the last problem. Okay, so let's discuss the last problem. So this in this problem we have given an array arr. So a peak is defined if any index I is greater than the previous index I minus 1, and it is also greater than the next index I plus 1, then it is a peak. So we have to do some range query on number of peaks, and we have also one operation which will be updating the peak value. So this is nothing but a straightforward segment tree. So mm, when we are changing one index, we'll change the, so we'll, along with the nums array, we'll also maintain one peak array. So let's say we have 3 1 4 2 5, right? So let's say our nums array is nothing but 3 1 4 2 5. Now we'll also maintain one peak array. Peak means that the this index is peak or not. This could be either 1 or 0. So the first and the last index are obviously not peaks, but is this index a peak? This is less than the previous value, so this index is not a peak. Now this index is a peak because this is greater than this value is greater than the previous index and the next index. So this is 1, so 0 0 1 0 0. Now we have to our segment tree will be a sum segment tree, and we will do range query on sum of on this segment tree, on this array, you can say. So if we do segment sum of the entire thing now, we'll get 1. But the operation, the first operation is the update operation. We are changing the value of the third index to 4. So we are changing the value of the third index to 4. So this index will be changed to 4. Now when we are changing this index to 4, then the peak value of this index may change, the peak value of the previous index may change, and the peak value of the next index also may change. So now the peak value of this index is not changing, but the peak value of the previous index is changing, because now this index is not greater than the next index. The peak value will change to 0. Okay, after that we'll have some update operation of gate operation of 0 comma 4. So the answer will be 0 here. Okay, answer will be 0 here. Our overall time complexity is order of n log n. So let's jump onto the code. So here it is just segment tree code. I have just copied from my repo. Okay, now we are updating the peaks. Initially all the segment trees are marked with zeros, so I am only changing the peak values when the peak is 1. So if the current index is greater than I plus 1 and the current index is greater than I minus 1, we are updating the peak value with 1. Okay, now if it is if this is the update operation, we are taking I equals to query 1 and val is equals to query 2. Now if I equals to 0, I greater than 0 and I less than n minus 1, then only this element can be a peak. So is peak after is val greater than nums I plus 1 and val greater than nums I minus 1. You can take nums I also here, and we are updating the value of is peak the current index with is peak after. Here one thing to observe is that we are using one based indexing in our segment tree. You can use zero based indexing also. Now this part is to change the peak value for the previous index. So if I minus 1 is greater than 0, then the previous element is eligible for a peak, and we are checking if it is changed to a peak or not. If it is changed to a peak, we'll update the value. Similarly thing for the next index, we'll check if it is a valid candidate for peak or not, and we are updating the value simultaneously. And another important part for the query operation, here I have missed in my first run, is that let's say this, there is a statement here: the first and the last element of an array or a sub-array cannot be a peak. So here let's say our peak array is something like this, uh, 0 1 0 1 and 0. Let's say we are trying to find the number of peaks in this range. In this range, this value this value becomes the first value and this value becomes the last value. So if we take the sum of the entire range, the answer will be 2, but the answer should be 0 here because this and this index should not be considered in this subarray. So we have to take the range L plus 1 and R minus 1. So we are only taking this specific range. So the answer will be 0 here. So that's why we are doing for the query we are doing L plus 1 and R minus 1, as we are using one based indexing, so it is becoming L plus 2 and R. Okay, I hope you got the explanation. If you have still doubt in any part of the code or explanation, you can always ask in the comment section. If you like the screencast and the explanation, please like the video and subscribe to my channel. Thank you.